Welcome back to another deep dive. Today we are dissecting a spec sheet for a piece of hardware with a name that sounds like a randomly generated password.
Yeah, it's definitely a mouthful. The NTI ST-IPHD-R-PoELC.
Right.
But what that really means is low-cost HDMI over Gigabit IP extender.
And that's our mission for this deep dive. We want to cut through the jargon and explain how this little box solves a really common problem.
A physics problem, really.
Exactly. We've all dealt with it. You get an HDMI cable that's maybe 50 feet long and the signal just dies.
It falls off a cliff. And to go further, you normally need these really expensive active cables or even fiber optics.
But this thing takes a completely different approach. It sort of ignores the HDMI limit entirely.
It does. It uses the Ethernet cables that are probably already in your walls.
And the claim is huge. It can push a 1080p video signal up to 393 feet. That's what, 120 meters?
Over standard Cat 5e or Cat 6, yeah.
So let's be clear for everyone listening. This is not just a passive adapter, is it? You can't just splice some wires together.
Oh, no, not at all. That would not work. This is active hardware. It's taking the video and audio, and it's actually encoding it.
Into what? Like data packets?
Exactly. It turns your video source into a multicast stream that runs over a standard gigabit network.
Okay, but that raises a bit of a red flag for me. If you're encoding, you're talking about compression.
You are.
And streaming usually means, a drop in quality or that annoying buffering wheel.
That's the key trade-off. To make 1080p fit, it uses the H.264 codec. So yes, it is compressed. It is not a raw video signal.
So you probably wouldn't want to use this for, say, high-end video editing where every single pixel matters.
Precisely. But for digital signs in a store or a presentation in the classroom, it's going to look visually lossless to the naked eye.
What about the other big issue with compression? Latency.
Good question. The spec sheet says the encoding delay is just 22 milliseconds.
22? It's actually a lot faster than I expected.
It's roughly 1 frame of video. So for watching a movie, it's effectively real time. You won't notice it.
Let's talk about the installation side. The model name has PoELC in it. I'm guessing that's power over Ethernet.
Correct. Class 3 PoE. And this is a really big deal.
Why is that?
It means the remote unit, the one behind the TV, gets its power directly from the network switch.
So no power brick, no ugly wall wart you have to try and hide.
Exactly. If you've ever tried to mount a TV flush against a wall, you know that power supply is the biggest headache. This gets rid of it.
That's a legitimate labor saver.
Yeah.
Now, the documentation also talks about point-to-many.
Right. This is where that multicast technology is so powerful. You can plug one transmitter into, say, a cable box and have it broadcast to up to 253 different receivers.
253 screens showing the same thing. That's incredible for, like, a sports bar or an airport. But what happens to the rest of my network?
That's the gotcha.
I knew there'd be one.
If you just dump that much video data onto a regular office network, you'll absolutely choke it.
Right. Your email server just grinds to a halt.
So for anything beyond a simple one-to-one setup, you need a managed switch.
You have to build a sort of wall around the video traffic.
You do. You use VLAN's virtual local area networks. You basically create a dedicated lane on the highway just for the video packets.
So plug and play comes with an asterisk.
That's a fair assessment, yes.
Okay, one last feature I want to touch on, the IR control.
Yes.
Because if my cable box is in a closet 300 feet away, how do I change the channel?
They thought of that. The receiver unit has a little 3.5 millimeter jack for an infrared sensor.
Yep.
You print your normal remote at the TV, the sensor catches the signal, sends it back over the Ethernet cable, and the transmitter blasts it at your cable box.
So it's like a virtual extension cord for your remote control.
That's a perfect way to describe it. It keeps the user experience the same.
So let's just boil this all down. For about $80, you get a remote unit that pushes video almost 400 feet, uses wiring that's already there, and needs 0 power outlets at the screen.
It's a really compelling package, especially for businesses. It basically turns video distribution into a standard IT task instead of a specialized AV project.
And that leads me to a bigger question, a final thought. If distributing video becomes this cheap, this easy, what does that do to our buildings, to our shared spaces? We talked about 253 screens. When the cost of putting a moving image on a wall drops this low, does the screen even matter anymore?
That's a fascinating point. You move from a world where a screen is a destination to a world where video could just be, well, digital wallpaper, just part of the ambiance.
Something to think about the next time you're in an airport. That's all the time we have for this deep dive. Thanks for listening.